Hello guys, welcome to the video on how to find out the center of mass of annular half disk. So this is the scenario of annular half disk of internal radius R1 and external radius R2. So the mass is spread uniformly over the disk part of radius R2 minus R1 here. So there is no mass here in this empty area. So I have chosen the elemental strip of mass dm, and the width of the strip is dr, and the strip is at a distance of r. So this is like a semicircular wire or semicircular ring which I have chosen as a elemental strip. Now since mass is distributed uniformly over the surface, we choose the surface mass density sigma, which is dm over dA, which is the entire mass m over the area of this annular half disk. So the area of this annular half disk is pi r2 square by 2 minus pi r1 square by 2, because there is no mass here in this empty part and there is only mass spread over here. So pi r2 square by 2 will give you the will give you the area of the half circle, but I want only this area, so I will subtract this the semicircle of radius r1 area. Then this will be sigma is equal to dm over dA, which is equal to the entire mass by pi r2 square minus pi r1 square by 2. So now I can write dm is equal to, this 2 comes up, this is 2m by pi into r2 square minus r1 square into dA. So this is the mass of this strip which I have chosen. So this, let this be origin. Now this is a strip which is in the form of a semicircular wire, and we know for a semicircle there is no coordinate of center of mass along x, and the coordinate of center of mass along y is 2r by pi. So 2 into, since the radius is r, I'll write it as 2r by pi. So let us, and the coordinate of center of mass of this strip is 0 along x-axis. So now we'll find out the center of mass is annular half disk. So from the definition, there is no center of mass of this annular half disk along, there is no coordinate along x-axis, because by symmetry we can see the center of mass lies anywhere in this y line, so y-axis. So we'll find out for y. So let me write y cm is equal to integral y dm over the entire mass. So if we could solve for this, that would be the answer of center of mass of this angular half disk. Now we know what is y, which is 2r by pi, and dm is 2m by pi into r2 square minus r1 square. And let's solve for what is dA. So dA is the area of this strip. So this strip is in the form of this is a very thin strip which is in the form of a semicircular wire. If you could take this out and stretch, it would look like a wire in this way, and length of wire is, which is simply pi r, which is the length of the wire, which is pi into radius, and width of the strip is dr. So it looks like a rectangle, so the area of rectangle is simply dA is equal to length into breadth, which is simply pi r dr. So dA is pi r into dr. So let's substitute everything here and solve for ycm. So ycm, coordinate of y, center of mass, is integral y is 2r by pi into dm is 2m by pi into r2 square minus r1 square into dA. So 2m by pi into r2 square minus r1 square into dA divided by the entire mass. So you can cancel m. So I left with integral 2r by pi into 2 by pi times r2 square minus r1 square into dA. What is dA? dA is pi r into dr. So pi r into dr. So also pi gets cancelled. So let me take out the constants outside the integration. 2 2's 4, and pi comes out along with r2 square minus r1 square, and inside the integration you have r into r, which is r square dr. Now what are the limits of this r? So if you could look the figure, so the limits of r starts from this point and ends at this point. So limits of r is from not 0 to r2, but it is from r1 to r2. So the limits would be r1 to r2 r square dr. So this is again 4 by pi into r2 square minus r1 square. Now what is the integration of r square? It is r cube by 3. So r cube by 3, and the limits are from r1 to r2. So if you substitute limits, so you would get 4 by pi into r2 square minus r1 square multiplied by, if you substitute the upper limit, it is r2 cube by 3 minus lower limit is r1 cube by 3. So this is r2 cube minus r1 cube divided by 3. So the final answer would be 4 by 3 pi times r2 cube minus r1 cube divided by r2 square minus r1 square. So this is the final answer. So this is the center of mass of an annular half disk. So this is YCM, which means the center of mass lies at a distance of r2 square, r2 cube minus r1 cube by r2 square minus r1 square into 4 by 3 pi. So this is the y coordinate of center of mass, which is at a height from the origin. So hope you understand. Thanks for watching the video.